Then you will learn how to divide radical expressions. Sometimes when you divide radical expressions, you can actually divide within the roots to get rid of your fraction, but sometimes you can't, like if they don't have a common factor. So what you would need to do then is to do what we call rationalizing. Rationalizing is when you get rid of the square root in the denominator. Oftentimes, teachers don't like to have that square root in the denominator, so you would need to rationalize. How do you rationalize? Well, it depends on what type of problem you have. If you have a monomial, which is just one term, you would rationalize by multiplying both the numerator and denominator, but by the root of the denominator. So why do we do that? Say I have square root of 5 times square root of 5. Remember how I mentioned this on the other lesson? This would equal 5. You know it's going to get rid of your square root because it's square root of 25, which is 5. If you have a cube root, you would need to do this twice. So square root of 5, cube root of 5 times cube root of 5 times cube root of 5 is the only way you will get 5. Because this is the cube root of 125, which would be 5. If you have a fourth root, do it 4 times and so forth. We will go over the other type of rationalizing later. So for the first one, first I would look to see, can I actually divide these, which I can. 8 divided by 2 is 4, and they both have a square root, so I can do that, keep your square root. And then square root of 4 is 2. That's by far the easiest way to do it. But what if you can't? 2 and 7 I can't divide. This is where you have to rationalize. So I need the denominator not to have this root. This is a square root, so I only need one more. So multiply by square root of 7. Whatever you add here, you must add to the numerator. So now in the numerator, I have square root of 2 times square root of 7. They're both under the root multiply. Here, this is square root of 7 times square root of 7. Remember, the square root of 49, which is 7. The short way of doing it, just cancel your root and write the number. Now, can I simplify this? You absolutely cannot. The 14 is under a root, the 7 is not. So that's as far as you can go. Now, if the 14 would have been outside, then yeah, I could have done that. All right, number 3, I have square root of 1 times square root of 5, so I need to rationalize this. This is, first of all, this is the same thing as saying square root of 1 over square root of 5. Okay, I could go ahead and get the square root of 1, which is 1, but I'm just going to go ahead and rationalize, multiply top and bottom by the same thing. Square root of 1 times square root of 5 is square root of 5. Over here, I would just get 5. Again, you cannot simplify that. All right, number 4, I have square root of 4 over square root of x. I can simplify the top. This is 2 over the square root of x. Now rationalize, multiply the numerator and the denominator by the square root of x. So 2 times square root of x, the 2 is not under a root, so it's just 2 square root of x. The denominator, square root of x times square root of x is x. Can't cancel again. All right, here, this is the cube root of 9. I can't simplify that. 3 times 3 is 9. I need at least 3. So to simplify this, I need to multiply this 3. I need 3 of them. So here I just have 1. So I need that. And I need 1 more. Do you see that I have 1, 2, 3 now? What did I add? This one was already there. I just added these 2, so I would need to add those 2 up here. And we're multiplying. Now we need to simplify. So bring your 3 down, keep your cube root. 9 times 9 is 81. Over, you know the denominator, the cube roots will cancel, you'll just have 9. Can I simplify this? Yes. First, we're going to do, what is the cube root of 81? Do your tree. This is 9 times 9. This is 3 times 3. 3 times 3. I need 3 since it's a cube root. Okay, so I'm going to bring this 3 down. So that's 3 times. Here I have a 3 that comes out, and then I have a 3 left over 9. Okay, 3 times 3 is 9 over 3 cube root of 3 over 9. These are both outside your root, so they'll actually cancel out, and the final answer will be the cube root of 3. Okay, number 6, this is a square root, so I just need one more. So multiply by the square root of 8x over the square root of 8x. So in the numerator, I have 3 square root of 8x because the 3 does not have a root. Here, those will cancel. You'll just get 8x. Can I simplify the 8? You sure can. That's 4 times 2. 2 times 2. Here's my pair. So it's 2 square root of 2. So this will equal 3 times 2 square root of 2. I can't simplify that x because I need at least 2. So this will equal 3 times 2 is 6 square root of 2x over 8x. I can simplify 6 and 8 by 2. So divide both of these by 2 to get 6 divided by 2 is 3, 8x divided by 2 is 4x, and the root stays the same. So that would be our final answer. Here's my number 7. I'm going to rewrite it so we can see. So I have x over square root of 5, rationalized by multiplying the top and the bottom by the square root of 5 to get x square root of 5 over 5. Can't simplify that. All right, number 8, we have a 5th root. That means I need 4 more. So you're going to multiply these by 4 of them. You know, instead of me writing it out 4 times, I could just do this to the 4th power. Remember, that means write it 4 times. So I'll do the same thing here. That's a 4. Okay, so how do we simplify that? All right, we have 8 to the 4th power is the first thing you need to do. That is 8 times 8 times 8 times 8. That will be 4,096. Okay, remember when you're doing exponents, I can multiply my exponents. So 9 times 4 is 36. And b times 11 times 4 is 44. Okay, that's definitely the easier way to go. In the denominator, those will cancel. The root part will cancel. You'll just have the numbers at the bottom. Okay, now I need to simplify this. It looks very complicated, but we can do this. So 4096, I need to know what the cube root of that is. This is 64 times 64, just because I know it's 8 to the 4th. 8 times 8, 8 times 8. Look, I have 3 right here. Since I'm looking for a cube root, let's keep going. I can do 4 times 2. I can do 2 times 2. Ooh, look at that. So I have nothing left. That means this is a perfect cube root. So it's telling me that the cube root of 4096 is 8 times 2, which is 16. Check your work. Do 16 times 16 times 16. You should get 4096 if your math is right. Okay? So, because I had nothing left, so it's perfect. So now I have 5a times 16. Now we just need to simplify these letters. I wonder if there's anything that will be left. Maybe, yeah, I think so. So I've done the number. Here I have a to the 36. Remember, you divide 36 divided by 3 is 12. I shouldn't have written that cube yet. So I have 16 here, and then I have a 12. And then, what was this, 44? 44 divided by 3. How many times does 3 go into 44? I have 1. 1 times 3 is 3. Subtract 14. 3, 4. 4 times 3 is 12. 2. So it looks like 14 times, so 14 b's will come out and 2 b's will be left. This was a difficult one I chose. I'm glad I did though, so you can see how it works out. So then in the bottom I have 8a, 9, b, 11. Let's go ahead and erase this to get some room. All right, now we need to do some multiplication to simplify. 16 times 5, I think that's 80. Then, well, you know what? Let's do it an easier way. Because if I do 80, I'll have a really big number, right? Guess what we could do? 8 and 16, you could simplify that. 8 goes into 16 2 times. Let's do that. That's going to cut your work in a little bit. So now I have 5 times 2 is 10. Then I have an A here. And then A here. So 12, 13 A's. And then I have B 14. Then you have your cube root of B squared. Over, in the denominator, I have A9, B11. Okay, last thing I need to do is to combine the variables outside. So here I just have 10. Remember what the quotient rule says, you subtract. 13 minus 9 is 4. 14 minus 11 is 3. And then I have cube root of b squared. You may need to watch this part over and over to understand it. Let's get into the second part of rationalizing. Next, we're going to look at how to rationalize binomials. Like if you have more than one term. If you have more than one term, you will need to multiply the numerator and the denominator by what we call a conjugate. A conjugate is the same binomial with the opposite sign in the middle. So say I have x plus 4, its conjugate would be x minus 4. So just change that middle sign. Even if it's a negative, if I have negative 4 minus square root of 3, the conjugate would be negative 4 plus square root of 3. All right, so that's how you do these. You multiply the numerator and the denominator by the conjugate of the denominator. That's the only way I'll get rid of the square root. So let's work these out. So number 1, put parentheses because it's a binomial. You're going to multiply by this conjugate, 2 plus square root of 7. If I multiply that by that, whatever you do to the denominator, you must do the exact same thing to the numerator. So on the numerator, I just need to distribute 6 times 2 is 12. 6 times square root of 7. Remember, the 6 does not have a square root, so that's just 6 square root of 7. In the denominator, you are going to use the FOIL. 2 times 2 is 4. 2 times square root of 7, again, that's 2 square root of 7. Negative square root of 7 times 2 is negative 2, comes outside because it's still outside. And then negative square root of 7 times positive, that's a negative square root of 49, or you can just write 7. All right, the top stays the same. There's nothing we can do there. Here you need to work things out. So I have my 4. These are like terms. They must cancel. If you're doing it correctly, you'll have one's positive, one's negative. So you want them to cancel so you can get rid of your root. Minus square root of 49 is 7. Okay, so 12, again, the numerator, I can't really do anything. But in the denominator, 4 minus 7 is negative 3. Can I simplify this? Yes, because 3 goes into 12 and the number out here. If there's no number, then you can't simplify. It has to be all 3. Divide all those by 3, and since it's negative, bring this negative out here. So I have my 12. Oh, well, the 3 is going to go. No, we're not going to do that. Okay, so do 12 divided by negative 3 is negative 4. 6 divided by negative 3 is negative 2. That's as far as you can go. Let's do more examples. So here I have another minus. The conjugate would be the same thing, but put a plus. If I add that to the denominator, I must add the same thing to the numerator. Okay, now distribute. Negative 7 times square root of x is negative 7 square root of x. Negative 7 times 3 is negative 21. Square root of x times square root of x will be x. Or you can write square root of x squared, which will be x. Square root of x times 3 is 3 square root of x. Here we'll get minus 3 square root of x. And then negative 3 times 3 is negative 9. I can't simplify the top, so I'll just leave it. In the denominator, I can't do anything with that x. These will cancel, bring down your 9. So on this one, that's as far as you can go. Okay, number 3, we're only worried about the conjugate of the denominator, okay? So multiply this by its conjugate, which will make it a minus square root of 3. Do the same thing up here, and since this is a binomial, put parentheses on that as well. Now start to distribute. Square root of 2 times square root of 2 is 2. Square root of 2 times negative square root of 3, they're both under the square root, so that's square root of negative 6. Negative, again here they're both under, so square root of 3 times 2. And then negative times a negatives, a positive. Here I have square root of 3 times square root of 3 is 3. Remember, when you have the same thing, you just cancel the square root. Denominator, square root of 2 times square root of 2 is 2. Square root of 2 times a negative is a negative square root of 6. Positive square root of 6. Minus, because we have a minus and a plus and a minus, that's a minus. Square root of 3 times square root of 3 is 3. Okay, combine your like terms in the numerator. I have 2 plus 3 here is 5. These do not cancel, they're minus and minus. It's like saying negative 1 minus 1, that's negative 2 square root of 6. In the denominator, I know those will cancel, and then 2 minus 3 is negative 1. So you can simplify negative 1 no matter what. Just divide these by negative 1. Okay, so you'll get 5 divided by negative 1 is negative 5. Negative 2 divided by negative 1 is a positive 2 square root of 6. Okay, this is one of the sections a lot of people struggle with. So I would just encourage you to take your time, pause, write your notes, do what you gotta do to understand it. Multiply by the conjugate of the denominator, that would be 4 square root of 3, change that middle sign. What you add to the bottom, add to the top. All right, now we just need to work this out. So you multiply these two numbers outside together. 2 times 4 is 8. Numbers inside together. Square root of 3 times square root of 3 is 3. So I can just write 3. All right, next I'll do this. The 2 stays outside. It's a plus 2. Square root of 3 times square root of 6 is square root of 18. Now do this one. Square root of 6 times that. That's a plus. The 4 stays outside and still have my square root of 18. Square root of 6 times square root of 6 is a 6. Okay, same thing in the denominator. 4 times 4 is 16. Square root of 3 times square root of 3 is 3. Okay, 4 square root of 3 times square root of 6 is plus 4 square root of 18. Next is these. The 4 is outside, so minus 4 square root of 18. And then negative and positives are negative. Square root of 6 times square root of 6 is 6. Now combine your like terms. So on top, 8 times 3 is 24. I can combine these because I see a square root of 18. So 2 plus 4 is 6, square root of 18. And then bring that 6. We'll combine that in the next step. 16 times 3 is 48. These will cancel, and then minus 6. Okay, I can add 24 plus 6 to get 30, plus 6 square root of 18. 48 minus 6 is 42. What can we simplify? Do you have a number that can go into 6, 30, and 42? Yes, 6 can go into all of those. So divide them by 6. 30 divided by 6 is 5. 6 divided by 6 is 1. You don't need to write the 6. 42 divided by 6 is 7. Last thing I see is we can simplify that square root of 18. It's 9 times 2, 3 times 3. Here's my pair, so that's 3 square root of 2. So I have, okay, I'll come up here. I have 5 plus 18 is the same thing as saying 3 square root of 2 over 7. If there was something I could that go into all three of these, I would do it, but there isn't. All right, that was a long one. Last one is this one. Multiply by the conjugate. So that's 2 square root of A plus square root of B. You're going to multiply the same thing here. 2 square root of A plus square root of B. All right, let's start the FOIL process. 2 stays out. Square root of A times square root of A is A, so that's just 2A. 2 times A is 2A. Square root of A times square root of B is square root of AB. Okay, I want to make this neater. Okay, so we're here. Square root of AB. 1 times square root of 2A squared, 2 square root of A. And then 1 times square root of B, you don't have to write that 1, is square root of B. Over 2 square root of A times 2 square root of A. 2 times 2 is 4. Square root of A times square root of A is A. 2 square root of A times B is plus. 2 is on the outside, and the inside just put those variables. Same thing here, but it's a minus 2 square root of AB. I always write it alphabetically. And then we have a minus. Negative times a positive is a minus. Square root of B times square root of B is B. Okay, combine your like terms. Where will I go? Okay, I think it will fit right here. All right, so 2A does not have a like term. Here, these are, nope, no like terms actually. We do not have one like term because this one's AB and this one's an A. Was it supposed to be an A? Yes, there's no like terms in the numerator. Okay, I need to go ahead and erase something to get some room. I'll erase right here. So what I'm gonna do is I realize that this is probably a longer problem. So I just wanna make sure I have enough room on my board. Okay, I think that should be good. Okay, I'm gonna come up here. So I established that there's no like terms here. So just rewrite that. So 2A plus square root of AB plus 2 square root of A plus square root of B. What about the denominator? 4A is just 4A. You know your middles should cancel, then just bring your B. So this is an A. That's as far as you can go.